couple of sequences questions here. First of all, x minus 4, x plus 2, and 3x plus 1 are three consecutive terms of an arithmetic sequence. Right, arithmetic sequence, that means we're just adding the same amount every time. For example, 7, 11, 15 is an arithmetic sequence because we're just adding 4. So I know I'm adding something to this one to get this one. And I can work out what it is by doing x plus 2 minus x minus 4. That's going to be my common difference. In fact, that ends up being x plus 2 minus x plus 4, it's 6. But here's the thing, like I've just kind of worked out that one, I can do the same over here. 3x plus 1 minus x plus 2, again, I need a bracket there, is going to equal 2x plus 1 minus 2, 2x minus 1. Therefore, 2x minus 1 must equal 6 because both of these are the common difference. And we could have just gone ahead and said that this equals this from the very beginning. I just thought I'd actually work out what the common difference was. 2x is then going to equal 7. X is going to be 3.5 or 7 over 2. And it's not a bad idea to just sub it back in and check that you get an arithmetic sequence just in case I've made a mistake. So then I would do 3.5 minus 4, that would be minus 0.5. Then I'm adding 3.5 to 2, that would be 5.5. So it's going up by 6, as you can see. And then 3.5 times 3 is 10.5. Add 1, we get 11.5. Again, I'm adding 6. So I can put a smiley face. That's got to be right. Next up, three terms of a geometric sequence. All right, let's go for it. So geometric sequence, we are timesing by the same thing each time. So maybe 3, 6, 12. This time I'm timesing through by 2. It's going to be a very similar method because to work out what I'm timesing by, I would do 6 divided by 3 or 12 divided by 6. Same approach here then. Y plus 2, right? This time I'm not going to, like, it worked quite well there, simplifying it. It's not going to be quite as easy this time. So y plus 2 over y minus 4 is how we get the what we call the common ratio. That's that one there. But I also get it by doing the third term divided by the second term. 3y plus 1 over y plus 2. And we've created an equation involving algebraic fractions. I'm going to cross multiply now. Essentially, I'm timesing both sides by y plus 2 and both sides by y minus 4. I'll get y plus 2 squared equals 3y plus 1 y minus 4. I'm going to end up getting a quadratic equation to solve. I think it's going to lead to two values by looking at that. That's just come, doing these before. But don't worry about that. Just go with it. So multiplying the bracket out here. Remember, I have written it as y plus 2 squared, but it's y plus 2 times y plus 2. So when you expand the bracket, you get y squared plus 4y plus 4. And that's going to equal 3y squared minus 12y plus y. It's going to be minus 11y. I'm doing this quite quickly, but I'm hoping you're happy with expanding brackets like that. Minus y squared from both sides, minus 4y from both sides, and minus 4 from both sides. I'm going to get that. Okay, we could just put this in the quadratic formula. I'm suspecting it's going to factorize, so it's up to you. But if it's going to factorize, it would be 2y and y. And then I've got an 8 here, so I suspect I'm going to put 8 here and 1 here. I know I need like an odd number overall, so I had to have an odd number here because I'm going to get, when I do 2y times whatever's there, I'll get an even number. Anyway, it's going to work. I'm going to put a minus there and a plus 1 there. So y is equal to minus a half or 8. And yeah, that's it. Both of these are valid. You could then put it back in again. Let's do it. 8's going to be a little bit nicer. So I think if it works for 8, you can be pretty happy. You don't have to put it in for minus a half as well. So then we would get 4, 10. Oh, I'm timesing by 2.5, I think. And then this one here would be 25 again, times in by 2.5. Nice one.